Hello everyone, in this video I am going to explain about what is point load, what is uniformly distributed load and uniformly varying load. In practical, where do we use to calculate these three types of loading while designing the structure that we will see in this video. What is point load? While calculating the shear force and bending moment, we always have a load of point load in any condition of the supporting system like simply supported or cantilever or fixed support. We always have a load of point load. So, what is point load? The place where you have to consider the load as a point load are the first point, load from the secondary beams to the main beams. Which means if you have a floor plan like this, there is a floor plan of assume there is a four side of beam here, this is a beam, and you have a column all four the side, and we are introducing one secondary beam at here. We are dividing this slab equally by introducing this secondary beam. What is happening here? The load distribution will be like this. This trapezoidal will be along the longer direction and this triangle will be the shorter direction. So, this much area of the load are coming to this beam as a UDL. So, we have to calculate this area and apply the load as a UDL load. How much we are considering the floor load? Say like dead load of self height plus floor finish and live load of 2 kilonewton per meter square. This will be your load on the slab as a floor load. Into this area you have to calculate, then it will be like load in kilonewton. This is at 45 degree inclination, this is also 45 degree inclination. So, this much area is the load coming to this beam as a UDL load. How you have to calculate is, you have to multiply total load in meter square, then you will get load in kilonewton. Load on the beam is equal to area into total floor load. So, you will get, based on this you will get area in meter square into load load in kilonewton per meter square. You will have a load in kilonewton. So, you will get load in kilonewton. Now, what you have to do? You have to do whatever the load in kilonewton that divided by span of this beam. In meter, you will get load in kilonewton per meter. So, this beam will be having a UDL load. Then what you have to do? The off portion of this load, the half of this load will go as a concentrated load to this beam. For an example, assume like this is the span of 5 meter and your load in kilonewton per meter is 10 kilonewton per meter. So what you have to do, assume this is 10 kilonewton per meter and the span is 5 meter, then your load will be 5 into 10 divided by 2 is equal to 25 kilonewton. You will have a concentrated load of 25 kilonewton at here on this beam as well as on this beam. So this is how the concentrated load coming on the beam as a point load. I hope you understand how the concentrated load are coming while designing the structure in practically where we can use this concentrated loader, which means the load from the secondary beam to the main beam, it will be have a concentrated load because this beam is resting on these two beams. So whatever the load coming from the slab to this beam will carry a UDL load, and this UDL load will be distributed equally to this and this as a concentrated load. And the second one will be hanging load. The second one is a hanging load. The other cases can be like hook, hanging in hook or anything. If there is a beam like this, you are hanging something on this hook. This hook is carrying some load, carrying a machine or whatever. This hook is subjected to the point load. This hook is subject to the point load. This load will be come to this beam as a point load. So if you have a similar case like this, then you have to consider that load as a point load. The second one we will discuss about uniformly distributed load. We call in short as a UDL. So which are the cases you have to consider the load as a UDL load that we will discuss now. So the first one is brick wall or RC wall on the beam. For an example, if you have a beam like this, and you have a brick wall on this or RCC wall on this, so this is your beam, this is your RC beam. This is your RC beam, and this beam is carrying a wall load like this, and this wall load to be calculated as thickness into height into density. For an example, this wall is the thickness of 200 mm. Then the height is from this to this as 2 meter. Then the brick density we can consider as 20 kilonewton per meter cube. Per meter cube. So how we can calculate the UDL load, which means load per meter, which is thickness into height into density. So I take all these values in meter. 0.2 into height is 2 meter into density 20 equal to 8 kilonewton per meter. So this beam will be have a UDL load of, which means this is the support, and this beam will have a UDL of 8 kilonewton per meter. So we are dividing this beam in each meter. The thickness of the wall and the height of the wall is the same throughout this beam. So the load per every meter is the same as a 8 kilonewton per meter. So it's for each meter there will be a load of 8 kilonewton. In each mm also the amount of the load is same throughout the beam. That's why we are denoting this 8 kilonewton per meter. So if you have a case similar like this, which means the beam is carrying a wall of brick wall or RCC wall or some other partitions or some other load throughout the beam, it will be considered as a UDL load. You have to consider the thickness and the density and the height, and you can multiply and you can apply that as a UDL load as we calculated here. So the next point is the load from the slab to the beam. So whatever load carried by the slab will transfer the load to the adjacent beams. That beam will carry a uniformly distributed load from the slab. For an example, I draw slab like this, and I have beam all the four sides. Here there is a column. Based on the shorter span and longer span, it will be like either one way or two way. Assume like this is a two way, this is a two way, which means the longer span to the shorter span is not more than 2. So this will be like two way slab. The load distribution will be, like this, as I drawn in the previous example. Whatever the load coming to this beam will be this much as a trapezoidal load. This area will be calculated based on the floor load plus self height of the slab, and you have to apply this load as a UDL load like this. It is not necessary to have a column on all four corners. It can be like from the secondary beam to the, it can be the slab is resting on the secondary beam as well, which means I introduce some more secondary beam and the slab is resting on the secondary beams. Consider this is a big span of the building, and I am introducing beam here, and I am introducing again beam here. So this is a secondary beam which is resting on these two main beam, and this is a secondary beam which is resting on this main beam and the secondary beam, because the shorter one will be always behave as a main beam to this secondary beam. So this beam is resting on this main beam and this secondary beam. This beam will be have a concentrated load, and this beam also will be concentrated load at here. This beam also will be have a concentrated at this way. So this slab so this area will be coming as a UDL load, and this area will be coming as a UDL load. So when we talk about this beam will have a this beam will be have a UDL load and a point load due to this secondary beam, and this is a UDL load due to this slab, due to the load coming from this slab. Similarly, this beam will have a, consider this is a B1, this B1 beam will have a will have a uniformly distributed load due to this slab, and here there is a concentrated load due to this secondary beam. So I hope you understand how the point load and the uniformly distributed load coming to the picture while designing the structure. The third point is self height of the beam. If the beam is carrying a point load and a uniformly distributed load, along that load we have to consider the dead weight of the beam as well. For an example, this is a beam, consider this cross section, consider this RC beam cross section of 0.2 meter, and this one is 0.6 meter. This will be have a UDL load due to its self height, which means we have to multiply the 0.2 into 0.6 into density of the concrete is 25, which comes 3 kilonewton per meter. Due to its self height, this beam will carry a load of 3 kilonewton per meter. So these are the possible cases we have to consider the uniformly distributed load while analyzing the structure. One is brick wall or RC wall coming on the beam. The second one, load from the slab to the beam, and then third one is self height of the beam. Now the last one we will discuss about the uniformly varying load. We call it UVL. Uniformly varying load is similar to the uniformly distributed load only, but with respect to the height, if the height is not same and linearly increasing or decreasing, then we have to calculate the load as a uniformly varying load. For an example, there is a beam here. And you have a wall like this. For an elevation purpose or some other cases, you will have a wall like this. So you will have a wall like this. In these cases, in an example, this is 2 meter height. What you have to do? The same procedure only. Consider this is a brick wall. So the thickness of the wall is thick wall, 0.2 into 2 meter height into density of the wall is 20 equal to 8 kilonewton per meter. So the load will be uniformly varying load of the beam is here, this is a support, and it will be like having a varying load of here the maximum load is 8 kilonewton per meter to 0. It will be having a load like this. If your case is similar to like this, then you have to consider the load as a uniformly varying load. linearly increasing or decreasing height of the wall. As per the architectural requirements or some other cases, if you have a wall like that, then you will consider the load as a uniformly varying load. Then the second condition is earth pressure on the retaining wall. Here there is a retaining wall with the foundation. This is earth face. And there is a slab like this. This is your ground level. So, you will be having a soil like this. This soil will be acting as a uniformly varying load. The soil pressure will be like this. How we can calculate this is the earth phase. So, active pressure is, so to calculate the pressure, the formula is pressure equal to Ka gamma H. Usually we take Ka as 0.3, or this can be given by the geotechnical engineers also. So, I take 0.33 into density of the soil is 18 kilonewton per meter cube into height. I am considering this height as a 2 meter. 2, so it comes 11.88 kilonewton per meter square. So, the soil pressure comes to this retaining wall is from 0 to maximum of 11.88 kilonewton per meter square. For 1 meter width, I am multiplying this for 1 meter width. The load on this retaining wall 11.88 kilonewton per meter, which means it will be the retaining walls like this. So, the load of, for every meter the retaining walls goes throughout like this, and for every meter there will be a load of 11.88 kilonewton, here 0 and here 11.88 kilonewton per meter. So, this is how the uniformly varying load we calculated in the retaining wall. So, I hope you understand about the point load, uniformly distributed load and uniformly varying load, how we can consider it in practical while designing the structure. So, we will see in the next video. Thank you. Bye bye.